Hi, let me tell you about another great Manning book, Functional Programming in Scala, 2nd edition, written by Michael Pilquist, Runar Bjarnason, and Paul Cusano.
Functional programming, FP, is a paradigm that constructs programs using pure functions, which are free from side effects like modifying variables or interacting with I/O. This approach allows for clear iteration and data mutation without side effects, enhancing modularity and reducing bugs. We will demonstrate these advantages by refactoring a program with side effects into a functional one, focusing on referential transparency and the substitution model. Consider a Scala example of a coffee shop program initially plagued by side effects, such as charging a credit card, complicating testing and reuse. Introducing a payments object improves design and testability, but still results in complexity for multiple purchases. The functional solution modifies the buy coffee function to return a charge object with the coffee, separating charge creation from processing. This enables a buy coffees function to handle multiple purchases efficiently, simplifying testing and reuse, and combining charges to reduce transaction fees. This approach demonstrates how FP can streamline code design by pushing side effects to the program's periphery, while maintaining a pure core, enhancing modularity, and reducing bugs. FP relies on pure functions, which have no side effects and consistently produce the same output for a given input. For instance, converting an integer to a string always maps the same integer to the same string without affecting the program's state. Referential transparency, RT, means an expression can be replaced with its result without changing the program's meaning. A function is pure if applying it to RT arguments yields an RT result, allowing substitution without altering behavior. RT and purity are key concepts in FP, as shown in the buy coffee example. For buy coffee to be pure and RT, calling buy coffee with Alice credit card should be interchangeable with its output, a new coffee, in any context. However, its interaction with a credit card company makes it non-RT, as this interaction is observable and not captured by the return value. RT ensures a function's actions are fully captured by its return value, allowing for the substitution model of reasoning, which simplifies program evaluation by replacing expressions with their values, focusing on local expression effects and enhancing code reasoning. Purity in functions boosts modularity, as pure functions act as black boxes, separating computation from input and output, increasing reusability and composability. In the buy coffee example, removing the payment processing side effect improved the function's reusability and testability. This book introduces FP principles, covering foundational concepts such as iteration, data structures, and error handling. It aims to familiarize readers with FP's foundational idioms, preparing them for advanced functional design techniques. By maintaining a pure core and pushing side effects to the program's edges, FP enhances modularity and reduces the likelihood of bugs, leading to more efficient and maintainable code.
Get this book at manning.com